Hello, I'm going to go over this worksheet with you. How many valence electrons? It's elemental. And it talks about what valence electrons are. They are the outermost electrons in the furthest orbital or energy shell. And what we want to do is we're going to actually draw Lewis structures for each of these reactions, and we're going to draw lines to where the arrows are, or where the electrons are going to go. Okay, so I'll do several examples here. Lithium plus fluorine. So lithium, and if I look on here, lithium has, well, it has 3 electrons, but the first orbital is full. So that means first orbital full, it has 1 electron in its outermost orbital. That's why it's right here. Same with sodium. Sodium has a full orbital, a second full orbital, and then 1 extra electron out here. So there's a reason why the periodic table is set up like this, right? All right, so lithium. Let's draw the Lewis structure for lithium. 1 outer electron. Just that. Now I want to draw my fluorine. So I'm going to put fluorine over here. Fluorine, first orbital is full. Second orbital has 1, 2, 3, 4, 5, 6, 7 electrons. So my Lewis structure will have the 7 electrons in that outer orbital. 1, 2, 3, 4, 5, 6, 7. Now in a chemical reaction, what happens is fluorine wants 8 electrons. 8 is perfect. It would be so happy if it could pick up 1 more electron, very stable. Lithium is very unstable because of this 1 extra electron. It does not want that extra electron. So what it's going to do when these are going to chemically react is this electron here is going to get shared with fluorine, and this creates a bond between lithium and fluorine. So this electron fills up that orbital for fluorine. Okay, now it feels great. Fluorine's good. Lithium is more stable because it got rid of that one, and they're bound together. Let's do another one. Let's do the next one. Beryllium and oxygen. So beryllium, I look here, orbital full. Beryllium here has 1, 2 in its outer orbital. So 1, 2. Now we look at oxygen. Oxygen, first orbital full, then we have 1, 2, 3, 4, 5, 6. 6 in its outer orbital. 1, 2, 3, 4, 5, 6. Well, it would really like to pick up 2 electrons here, because remember 8 is perfect. It really wants to pick up 2, and fortunately beryllium has 2 to spare, because this 2 out there is unstable. So when they bond, one of these will go over here, and the other one will go right there. Then this will have 8, this will have 0, they'll be bonded together. All right, one more here. Calcium and fluorine. Calcium's right here. So first orbital full for calcium, second one's full, third one's full, which means that its outer one has 1, 2 electrons. So this calcium has 1, 2. Now you'll notice I have F2. That's a little hint. We're going to actually be drawing in 2 fluorines, and you'll see why here in a minute when we look at fluorine. It has a full orbital, and then 1, 2, 3, 4, 5, 6, 7 in its outer orbital. So fluorine, I'll do one here. 1, 2, 3, 4, 5, 6, 7. And then I'll do another one over here. 1, 2, 3, 4, 5, 6, 7. Again, the 7 is because we have 1, 2, 3, 4, 5, 6, 7 in the outer orbital for fluorine. Fluorine wants 8. That would be great. Calcium wants to get rid of both of these to be more stable. So to bond all of these together, let's see, this calcium will give up an electron here, and this one will give up an electron right there. And then that bonds all 3 of those atoms together. All right, I hope this helps. Try and do the rest on your own, and let me know if you need help.